Good morning, students. Welcome to the online classes. Today we are going to discuss about 9th class Physical Science Chapter 3 is Matter Pure. You are able to learn and end of this lesson is classification of matter, pure substances and mixtures, types of mixtures, true solutions, colloidal solutions, suspension, Tyndall Effect, concentration of a solution, separating the components of a mixture, evaporation, centrifugation, decantation of separating phenol by using separating phenol, sublimation, chromatography, distillation, simple distillation, fractional distillation. Separation of compounds, types of pure substances, elements, compounds, separation of components of air. After completing this watching video, students, you are doing some work, that is assignments, word search puzzle, question type puzzle, and some worksheets are completed. Come to the lesson. What is matter? We already learned about matter in the previous class, 8th class, matter around us. Okay, so matter on the basis of the physical state, matter is classified into three main types. They are solids, liquids, and gases. On the basis of chemical composition of matter is classified into two main types. They are pure substances and mixtures. Pure substances are two types. They are elements and compounds. Mixtures are two types. They are homogeneous mixtures and heterogeneous mixtures. Pure substances are classified into two types. Elements. What is elements? Elements cannot be broken down into simpler substances. Example of elements: iron, copper, oxygen, mercury, nitrogen, etc. And compounds, that means have a fixed composition, can be broken down into simpler substances. Example: water, alcohol, sugar, salt, butane, etc. And mixture, two types: homogeneous mixture, that means uniform compositions. Example: sugar in water, salt in water, water in alcohol, sulfur in carbon disulfide. And heterogeneous, non-uniform composition. Example: sand and sugar, salt and sugar, water in oil, sulfur and sand, etc. Dear students, observe this video, pure and impure substances.
We will learn about pure and impure substance. Do you go to the market for shopping? If you look closely at the cartons of milk, ghee, juice, etc. that are being sold in the market today, you will find 100% pure or pure written on all the boxes. Can you tell us what is the meaning of pure? For ordinary people like you and me, if there is no adulteration in anything, then according to us, that thing is pure. But does the same thing mean pure things in the scientific definition? No. When a scientist says that something is pure, it means that all the constituent particles of that substance are the same in their chemical nature. A pure substance consists of single type of particles. So now you must be thinking, what are impure substances? The substances that are formed by mixing two or more pure ingredients are called impure substances. They are also called mixture. Let us now learn more about pure and impure substances by some examples. Let us take an example of salt. Is salt a pure substance? For this, we will first check whether salt is made up of the same type of particles. Here, you can see the particles of sodium chloride present in the salt. Are these particles identical? Yes. The composition of salt is composed of molecules similar to sodium chloride. Therefore, we can say that salt is a pure substance. Friends, we know that salt is made up of sodium chloride molecules. Can we separate salt into elements of sodium and chlorine by some physical process? No. Therefore, we can say that we cannot separate pure substances into other types of elements by any physical process. Can you think of examples of more pure substances? Yes. Sugar, water, gold, diamond are examples of some more pure substances. Are the characteristics of 1 kilogram of sugar and 10 kilogram of sugar the same? Yes. From this, we can conclude that the characteristic properties of pure substances remain the same. Let us now look at the sugar and water solution. Is it a pure substance? Let us find the answer to this question by an activity. In a beaker, take this sugar and water solution and then heat it with the help of a burner. What do you see? Alright, sugar that was dissolved in water is separated from water due to evaporation. But can we separate sugars or water into their components by some physical process? No. From this activity, we can conclude that the solution of sugar and water is an impure substance or mixture, which consists of two pure substances, sugar and water. Can you think of more examples of impure substances? Potassium permanganate and water solution, tea, soil. These are some other examples of impure substances, which are made up of two or more pure ingredients. Friends, hope you have got a good understanding of pure and impure substances.
Dear students, are you understood this video? Okay. Next, pure substances and mixture. What is the difference between pure substance and mixtures? Pure substances is a substance which consists of a single type of substance, element or compound. Example, iron, copper, hydrogen, oxygen, water, sugar, common salt, etc. And mixture is a substance which consists of two or more pure substances. Example, seawater, minerals, soil, oil, air, sand and salt, sugar in water, salt in water, etc. Differences. Pure substances. Pure substance consists of a single type of substance. And mixture. Mixture consists of two or more pure substances. Pure substance. Second one. Pure substance cannot be separated into other substances by physical methods. Mixture. Second point. Mixture can be separated into its components by physical methods. Pure substances. Third point. Pure substance has its own definitive properties. Mixtures. Third point, mixtures shows the properties of its components. Okay, dear students, next let us learn about types of mixtures. Mixtures are of two types. They are homogeneous mixtures and heterogeneous mixture. Homogeneous mixture is a mixture which has a uniform composition. The particles of the mixture are not visible by the naked eye. The particles cannot be separated by filtration. The mixture is stable. The particles do not settle down. The path of a beam of light is not visible in the mixture. Example, mixture of sugar in water, mixture of salt in water, mixture of copper sulfate in water, etc. Next, heterogeneous mixture is a mixture which has a non-uniform composition. That means the particles are visible by the naked eye. The particles can be separated by filtration. The mixture is unstable. The particles settle down. The path of a beam of light is visible in the mixture. Example, mixture of salt and sand, mixture of sulfur and iron fillings, mixture of oil and water, etc. Students, observe this video.
Dear students, when we hear word pure, very first thing that strikes into our mind is anything which is not adulterated. Say, a ghee is said to be pure only if it's not adulterated. But ghee is also a mixture of many substances like fats, proteins, etc. So, modern scientists termed it as mixture rather than calling it pure. So what do you mean by mixture? A mixture is two or more substances mixed with each other where substances are individually distinct. A substance is a pure kind of matter which cannot be separated by any physical process. In mixture of salty water, salt and water are substances. So, on basis of nature of substances, mixture can be divided into homogeneous and heterogeneous mixture. Homogeneous mixture. Dear students, can you identify salt from the mixture of salt and water? No. This is because salt particles get evenly distributed among water particles. Mixture in which all the particles are evenly distributed, making a uniform composition, is known as homogeneous mixture. Some other examples are air, blood, tea, etc. Again, if you add 1 or 2 teaspoons of salt more to mixture, does the mixture seems to be same? Well, no. Mixture will show slight change in color. This shows that though both are homogeneous mixtures, still they have variable composition. Now what about heterogeneous mixture? It can be defined as mixture with non-uniform composition of substances where substance or their phases are easily distinguishable. Say, mixture of water and sand. Here, sand particles are easily identified. Hence, it is heterogeneous mixture. Some other examples are mixture of oil and water, salt and iron filings, etc. Let us now have a look on activity. What is solution? A solution is a homogeneous mixture of two or more substances. Generally, when we say a solution, a picture of liquid solution strikes in our mind. It's interesting to know that there are solid as well as gaseous solutions. In solution, Each and every particle follows homogeneity. This is the only reason your tea tastes same from the first sip to last one. So let me tell you a little more about solution. A solution is made up of components called solute and solvent. Component which is present in large quantity is called as solvent. Example, water. Component which is present in less quantity is called as solute. Example, salt, sugar, etc. Can you guess the properties of solution? A solution is homogeneous mixture. Particles of solutions are not visible to naked eye. Due to small size, they do not scatter beam of light, and so path of light is not visible. Solute particles present in solution are not separated from the solution by method of filtration. Solute particles in solution do not settle down if left undisturbed.
Dear students, understand this video? Okay, next let us learn about next topic is a true solution. What is a true solution? A true solution is a homogeneous mixture of two or more substances. A solution has a solvent and solute as its components. The component in the larger amount is the solvent, and the component in the lesser amount is the solute. Example, solution of salt in water, solution of sugar in water, iodine water, tincture of iodine, soda water, etc. Properties of true solutions. True solution is a homogeneous mixture. The particles cannot be seen by the naked eye. The solute particles cannot be separated by filtration. The solute particles do not settle down and the solution is stable. The particles do not scatter a beam of light passing through it, and the path of light is not visible in the solution. And next topic is, let us learn about the next topic is colloidal solution. A colloidal solution is a heterogeneous mixture of two or more substances. Example, mixture of starch in water, mixture of egg albumin in water, milk, air containing dust and smoke, etc. Properties of colloidal solution. Colloidal solution is a heterogeneous mixture. The particles cannot be seen by the naked eye. The solute particles cannot be separated by filtration. The solute particles do not settle down and the solution is stable. The particles scatter a beam of light passing through it, and the path of light is visible in the solution. Dear students, observe this video.
After learning solutions and suspensions, now you must be definitely curious to know about colloidal solution. So, let us learn what exactly a colloidal solution is. In colloidal solution, particles of colloid are distributed evenly in solution. These particles have smaller size as compared to size of particles of suspension. Since particle size is small, it appears to be homogeneous. But in reality, solution is heterogeneous. That is, when beam of light is passed through the solution, scattering of light is visible. That is, a Tyndall effect is observed. It is observed in dark room where beam of light enters from small hole, and in dense forest where particles of dust and smoke, tiny water droplets in air act as colloidal particle which allow scattering of light. Properties of colloid. A colloid is a heterogeneous mixture. The size of particles of colloid is too small to be seen by naked eye, but is big enough to scatter beam of light passing through it and make path of light visible. They do not settle down when left undisturbed. That is, a colloid is quite stable. They cannot be separated by process of filtration. Hence, technique of centrifugation is used to separate colloidal particles. After learning properties of colloid, you must be jumbled to decide whether a colloid is a solution or a suspension. Well, dear students, properties of colloid lies between solution and suspension. Here is a short comparison between solution, colloid and suspension. Components of colloidal solution. A colloidal solution contains dispersed phase and dispersion medium. Dispersed phase is made of solute-like particles or dispersed particles. A component in which dispersed phase is suspended is called as dispersion medium. Following table shows some example of colloids. Let us now have a look on activity. So here we complete the topic.
Dear students, understand this video? Okay, next. Let us learn about next topic is suspension. A suspension is a heterogeneous mixture of two or more substances. Example, solution of sand in water, solution of chalk powder in water, etc. Properties of suspension. Suspension is a heterogeneous mixture. The particles can be seen by the naked eye. The solute particles can be separated by filtration. The solute particles settle down and the solution is unstable. The particles of scattered beam of light is passing through it and the path of the light is visible in the solution. Dear student, let us learn about the topic is Tyndall Effect. When a beam of light is passed through a colloidal solution, the colloidal particles scatter the beam of light and the path of light becomes visible in the solution. This effect is called Tyndall Effect. Tyndall Effect can be seen when light enters a room through a small hole due to scattering of light by the dust and smoke particles. Tyndall Effect can be seen in a dense forest due to scattering of light by water droplets in the mist. Observe these pictures. Dear students, let us learn about next topic is saturated solution. Saturated solution is a solution which cannot dissolve any more of a solute at a given temperature. Solubility of a substance is the amount of solute present in a saturated solution of the substance. Unsaturated solution is a solution which can be dissolved some more of the solute at a given temperature. Preparation of a saturated solution. Take 50 ml of water in two beakers. Add salt in one beaker with continuous stirring till no more salt dissolves in it. Similarly, add sugar in the other beaker with continuous stirring till no more sugar dissolves in it. We get saturated solutions of salt and sugar. If the mixtures are heated, it dissolves some more of the solute. The solubility of different substances are different. The solubility of substance varies with temperature. Okay, next let us learn about the concentration of a solution. The concentration of a solution is the amount of solute present in a given amount of the solvent or solution. concentration of a solution is equal to amount of solute by amount of solvent, or amount of solute by amount of solution. The concentration of a solution can be expressed as mass by mass percentage, or as mass by volume percentage. Mass by mass percentage of a solution is equal to mass of solute by mass of solution into 100. Mass by volume percentage of a solution is equal to mass of solute by volume of solution into 100. Dear students, observe this video.
Dilute or concentrated bases. What do these words dilute and concentrated means? They specify the concentration of solution. A solution is said to be dilute if number of solute particles present in solution is less while solvent is present in larger quantity. A solution is said to be concentrated if large number of solute particles are present in solution. Also, each solution has a specific dissolving capacity of solute. Hence, when solution dissolves solute to its dissolving capacity, then it is known as saturated solution. Amount of solute present in saturated solution is called as its solubility. After solution is saturated, dissolution stops and solutes accumulates at bottom. If amount of solute present in solution is in less quantity than the dissolving capacity of solution, then it is known as unsaturated solution. So, concentration is defined as amount of solute present in given amount of solution, or amount of solute dissolved in given mass or volume of solvent. Concentration can be expressed in following two methods. Mass by mass percentage of solution, which is equals to mass of solute upon mass of solution into 100, or mass by volume percentage of solution, which is equals to mass of solute by volume of solution into 100. Let us now have a look on activity. Suspension. Suspension is a heterogeneous mixture where solute particles do not dissolve in solution and remain suspended in bulk medium. Let's discuss some properties of suspension. Suspension is heterogeneous mixture where particles of suspension can be seen with naked eye. Particles of suspension scatters beam of light, making path of light visible. Particles of solute settles down when suspension is kept undisturbed, and hence they can be easily separated by process of filtration. When particles settle down, suspension breaks, which also stops the scattering of light.
Dear students, understand this video? Okay, very good. The next topic is separating the components of a mixture. The components of a heterogeneous mixture can be separated by simple methods like hand picking, sieving, filtration, etc. Sometimes special techniques are used to separate the components of a mixture like evaporation, centrifugation, decantation using separating phenol, sublimation, chromatography, distillation and fractional distillation. Let us discuss about evaporation. This method is used for separating a volatile component or solvent from a non-volatile component or solute by heating the mixture. Example, ink is a mixture of a dye and water. If some ink is heated in a dish, the water evaporates and the dye is left in the dish. Similarly, we can separate a mixture of salt and water or sugar and water by evaporation. Next, centrifugation. The method of separating denser particles and lighter particles from a mixture by using centrifuging machine is called centrifugation. Example, if we take some milk in a centrifuging machine and spin it rapidly, the cream separates from the milk because cream is less dense than milk. And next, decantation using separating phenol. This method is used for separating a mixture of immiscible liquids. Liquids separate into different layers depending on their densities. Example, if we take a mixture of kerosene oil and water in a separating phenol, it forms separate layers of oil and water. The water can be separated by opening the stop cock. After the water flows out, the stop clock can be closed. And next topic is sublimation. Next technique is sublimation. This method is used to separate a mixture of sublimable component from a non-sublimable component by heating the mixture. Example, if a mixture of ammonium chloride and common salt is heated, the ammonium chloride sublimates and can be cooled and solidified and collected, and salt is left behind. And next technique is chromatography. This method is used for separating colored components from a liquid by using a filter paper or blotting paper. Example, put a drop of ink near one end of a strip of filter paper and dip the end of the paper in a test tube containing water. Ink is a mixture of two or more colored components. The component which is more soluble in water rises faster and get separated. And next technique is distillation. This method is used for separating a mixture of miscible liquids by boiling the mixture and cooling and condensing the vapors. Distillation is used for separating a mixture of two miscible liquids having sufficient differences in their boiling points. Example, if a mixture of acetone and water is heated in a distillation apparatus, the acetone, which has a lower boiling point than water, first boils and cools and condenses and is separated from the water. And next technique is fractional distillation. Fractional distillation is used for separating a mixture of two or more miscible liquids whose difference is in boiling points is less than 25 degree Kelvin. The apparatus used for fractional distillation is similar to that used for simple distillation, except that a fractionating column is fitted between the distillation flask and condenser. The fractionating column has glass beads which increases the surface for the vapors to cool and condense. Fractional distillation is used for separating the components of petroleum, separating the different gases from air, etc. And next topic is separation of components of Air. Air is a mixture of gases. The components of air can be separated by fractional distillation. Air is compressed by increasing the pressure and cooled by decreasing the temperature to get liquid air. The liquid air is then allowed to warm up slowly in a fractional distillation column. Then the different components separate at different heights depending on their different boiling points. Air. Air compress and cool by increasing pressure and decreasing temperature. And next technique is purification of solids by crystallization. Crystallization is the process of obtaining a pure solid in the form of crystals from its solution. Example, by crystallization we can obtain pure copper sulfate from its solution. Dissolve about 5 grams of copper sulfate in minimum amount of water. Filter the solution to remove the impurities. Evaporate the solution in a china dish to get a saturated solution. Cover the solution with a filter paper and allow it to cool. Pure copper sulfate crystals are formed. Dear students, observe these all techniques in this video.
Welcome to this video. In the previous video, we studied about solutions, suspensions, and colloids. In this video, we will study the separation of components of mixtures. As we know, most of the substances around us are found in the form of mixtures. A variety of methods are used to separate the components of these mixtures. But you may be wondering, why is it required to separate the components from the mixture? Separation makes it easy to obtain and use information about each component of the mixture. The heterogeneous mixture can be separated by simple physical processes such as selecting by hand, filtering and sieving, etc. But can we separate all the mixtures by physical processes? For example, can we separate ink into its components by some physical process? No. Special techniques are used to separate mixtures such as ink. Let us now study some of these techniques. First of all, we will learn about evaporation. Let's try to understand it through an activity. Fill half the beaker with water. Now, place the watch glass on the face of the beaker and put some drops of ink on the watch glass. Now, start heating the beaker. What do you see? We can see that evaporation is happening from the watch glass. We will continue heating the beaker until it evaporates. After a while, you will see that there is no change in the watch glass. Then we will stop heating it. Is there any residue left on the watch glass? Yes. We can see that the blue component, dye, appears as a residue on the watch glass. So, according to you, which substance has evaporated from the watch glass? Absolutely correct. Water? So we can now conclude by this activity that ink is a mixture composed of water and color components, in which water is a solvent and color is a solute. And we can separate the solute from the solvent in mixtures such as ink by evaporation. Let us now learn about the second technique of separation, centrifuge. Take milk with a little bit of whole cream in a vessel. Now, try to separate the cream from milk by filtering it with a sieve. Did you succeed in it? No. Why so? In fact, the particles of cream present in milk are so small that they come out of the filter container. Then, how can we separate mixtures such as milk with cream? Now, let us take this creamy milk in a test tube. Now centrifuge it for 2 minutes with a centrifuge machine. What do you see? When the centrifugal device is rotated rapidly, heavy milk particles settle down and light cream particles remain on top. Particles of creamy milk, blood, wastewater, etc. are too small that it cannot be separated by filtration, but can be separated by centrifugation. Now let us learn about the technique of separation of a mixture of insoluble liquids. In this activity, we will put a mixture of kerosene and water in a separation funnel. Now, we'll leave it undisturbed for a while. What do you see after a while? Yes, after some time, separate layers of water and oil are formed. But why so? This is possible because water and kerosene are insoluble liquids. Kerosene, being lighter than water, rises upwards to form a separate layer. And due to the water being heavy, it remains in the bottom layer. Now, we can open the stopcock of separation funnel carefully and remove the bottom water layer into a beaker. Close the stopcock as soon as the oil reaches the bottom. In this way, we can see that the liquids which are not soluble among themselves can separate into different layers according to their density. Therefore, with the help of the separation funnel, mixtures of insoluble liquids such as water and oil, molten iron and slag, etc. can be separated. Let us now learn about the next technique, sublimation. Take a mixture of salt and ammonium chloride in a ceramic cup. Now cover this cup with a funnel upside down and close the open end of the funnel with cotton. Now, heat the ceramic cup slowly using a burner. What do you see? As the cup is heated, the vapor of ammonium chloride rises upwards from the cup, and after some time, this vapor starts to settle on the cool surface of the funnel. Keep the ceramic cup warm until the vapor stops coming out of it. Now, turn off the burner and scratch out the solid ammonium chloride in a bowl. In this way, we separated the mixture of salt and ammonium chloride. But how was this possible? This was possible because ammonium chloride is sublimable substance that converts directly from the solid state to the gaseous state upon heating. By this activity, we can conclude that to separate such mixtures that contain a sublimable volatile component from a non-sublimable impurity such as camphor, naphthalene and anthracene, the sublimation process is used. The next separation technique is chromatography. Let us understand this by an activity. Take a thin layer of filter paper. Draw a line with a pencil 3 centimeters above its bottom edge. Now, place a drop of water-soluble ink in the center of the line with the help of a sketch pen. Allow this drop to dry. Now, take some water in a jar and keep this filter paper in such a way that it stays just above the surface of water. Now leave it undisturbed. What do you see? Different colors are seen on the filter paper. How did this happen? Why did this happen? As the water moves upwards on the filter paper, it also takes the dye particles along with it. Often the dye is a mixture of two or more colors. The color component, which is more soluble in water, rises faster, and thus the separation of colors becomes possible. This method of separating components from a mixture is called chromatography. It is a method used to separate solutes that dissolve in the same type of solvent. For example, in separating pigments from natural dyes, separating drugs from blood, etc. The next separation technique is distillation. Let us try to understand it through an activity. Take a mixture of acetone and water in a distillation flask. Put a thermometer in it. Now arrange the device in this way. Heat the mixture slowly and carefully observe the thermometer. As the mixture heats up, what do you observe? Vapor distillation of acetone appears to rise in the flask at approximately 56 degrees Celsius. This acetone vapor passes through condensation. It starts condensing and again accumulates in the beaker in the liquid phase. In this way, we can separate the mixture of acetone and water by distillation. This was possible because a mixture of acetone and water is a mixture of two miscible liquids that boiled without decomposition and have sufficient difference in their boiling points in between 56 degrees Celsius and 100 degrees Celsius. To separate a mixture of two or more miscible liquids for which the difference in boiling points is less than 25 K, fractional distillation process is used. You may be thinking that by fractional distillation method, we can only separate the mixture of liquids. But can we use the distillation method even if we have to separate the gaseous mixture? Let us know about this by the example of air. Air is a homogeneous mixture and its components can be separated by fractional distillation. Suppose we have to separate oxygen gas from air. To do this, first let us arrange the devices in this way. We have to separate the other gases
Dear
present
students,
in the air to
understand
get oxygen from
this
the air.
video of
To
different
obtain liquid
techniques.
air, the pressure on the air
Next
is
topic
first
is types of
increased
pure
and then
substances.
air is
Pure
cooled by
substances are
decreasing
of two types.
temperature.
They
This
are
liquefied
elements and
gas
compounds.
is slowly
Element.
heated
Element
in the
is a
fractional
basic form of
distillation
matter
column,
which cannot
where
be broken
all the
down
gases
into
separate
simpler
at
substances by
different
chemical
heights
reactions.
according to their boiling
Elements
points.
are of three types. They are
Now,
metals,
finally,
non-metals,
the last
and metalloids.
separation technique
Properties
is
of metals.
crystallization.
They have luster.
Take
They are
about 5
malleable and
grams of
ductile.
impure
They
copper
are good
sulfate in a
conductors of
ceramic
heat
cup.
and electricity. They
Dissolve
are
it
sonorous.
in minimum
Example:
amount of water.
iron, aluminium,
Filter
zinc,
out
mercury,
impurities.
copper,
Now
silver,
vaporize the
gold,
water with a
etc.
solution of
Properties
copper
of
sulfate
non-metals.
to obtain
They
the
do not have
saturated
luster.
solution.
They are not
Cover the
malleable or
solution with a
ductile.
filter paper
They are poor
and leave it
conductors of heat and
undisturbed at
electricity.
room
They
temperature
are
to
not
cool
sonorous.
throughout the day.
Example: hydrogen, oxygen,
What do you
nitrogen,
see?
iodine,
We can
carbon,
see that
sulfur,
there are
phosphorus,
crystals of copper
etc.
sulfate in the
Properties of
ceramic cup.
metalloids.
This
Metalloids are
process is
elements
called
which show some properties of
crystallization.
metals and
Now
some
you might be thinking
properties of
that which
non-metals.
mixtures can we
Example,
use to separate
boron,
by using
silicon,
this process. We can use
germanium,
crystallization
etc.
to
Dear
purify
students,
salt.
these
For
types of
example,
pure
when
substances
receiving
are
salt from
observed
seawater,
in this
it may
video.
contain many impurities. The crystallization method is used to remove these impurities. Crystallization is the method by which pure solids in the form of crystals are separated from the solution. And do you know, the crystallization method is preferable over a simple evaporation method for the following reasons. 1. Some solids disintegrate or some scorch when heated, like sugar. 2. Even after filtration, some impurities can remain in the solution if the impurities are dissolved in the solvent. These impurities can contaminate the solid when evaporated. Thus, according to the nature of the mixture, we can get pure substance by using any of the methods we have learned. Friends, today we studied separation of components of mixtures.
The next topic is types of pure substances. Pure substances are of two types. They are elements and compounds. First one, element. Element is a basic form of matter which cannot be broken down into simpler substances by chemical reactions. Elements are of three types. They are metals, non-metals, and metalloids. Properties of metals. They have luster, they are malleable and ductile, they are good conductors of heat and electricity. They are sonorous. Example, iron, aluminium, zinc, mercury, copper, silver, gold, etc. The properties of non-metals. They do not have luster. They are not malleable or ductile. They are poor conductors of heat and electricity. They are not sonorous. Example, hydrogen, oxygen, nitrogen, iodine, carbon, sulfur, phosphorus, etc. Properties of metalloids. Metalloids are elements which show some properties of metals and some properties of non-metals. Example, boron, silicon, germanium, etc. Next, let us learn about a compound. A compound is a substance composed of two or more elements chemically combined together in a fixed ratio. Example, water, carbon dioxide, sugar, salt, iron sulfide, etc. Differences between mixture and compounds. Mixture. First point. It is composed of two or more elements or compounds mixed together. Compound. First point. It is a composed of two or more elements chemically combined together. Mixture. Second point. The composition of the components is in any ratio. Compound. Second point. The composition of the components is in a fixed ratio. Mixture. Third point. It shows the properties of the components. Compound. Third point. It shows different properties than the components. Mixture. Fourth point. The components can be separated by physical method. Compound. Fourth point. The components can be separated only by chemical methods. Okay. Dear students, understood this topic, this lesson? Okay, next, summary of this lesson. A mixture contains more than one substance, element or compound mixture in any proportion. Mixtures can be separated into pure substance using appropriate separation techniques. A solution is a homogeneous mixture of two or more substances. The major component of a solution is called the solvent and the minor the solute. The concentration of a solution is the amount of solute in grams present for 100 ml or for 100 grams of the solution. Materials that are insoluble in a solvent and have particles that are visible to naked eye is called a suspension. A suspension is a heterogeneous mixture. Colloids are heterogeneous mixtures in which the particle size is too small to be seen with the naked eye, but is big enough to scatter light. Colloids are useful in industry and daily life. The colloid has the dispersed phase and the medium in which they are disturbed is called the dispersion medium. Pure substances can be elements or compounds. An element is a form of matter that cannot be broken down by chemical reactions into simpler substances. A compound is a substance composed of two or more different types of elements, chemically combined in a fixed proportion. Properties of a compound are different from its constituent elements, whereas a mixture shows the properties of its constituting elements or compounds. Okay, dear students, write an assignment. First Roman A, choose the correct option. That means multiple choice questions. First one, powder mixture of naphthalene and sugar can be separated with the help of dash process. Separating phenol, evaporation, sublimation. D, none. Second one, the pigments from plant leaves can be separated by dash. Evaporation, filtration, chromatography, distillation. Third one, a solution of alcohol and water can be separated using dash. Evaporation, distillation, chromatography, none of these. Fourth one, petrol is separated from petroleum using dash technique. Distillation, fractional distillation, boiling, none of these. And next Roman is fill in the blanks. First one, for commercially separating cream from milk, a dash is used. Second one, oil and vinegar form a dash mixture. Third one, milky glass is a dash solution. Fourth one, elements are classified into metals, non-metals and dash. Fifth one, colloidal particles are visible only under an dash. Sixth one, a binary mixture is made of dash components. And third Roman C, write the following questions. First one, how do we separate the salt and ammonium chloride? Second one, how does a laundry dryer squeeze out water from wet cloths? Third one, is it possible to find out adulteration of kerosene in petrol with evaporation technique? Fourth one, is full cream pure? And fourth Roman D, match the following. Column A, pure substance and impure substance, ice cream, ethyl alcohol plus water, binary compound, solubility does not increase with the rise in temperature. Column B, colloidal, fractional distillation, air, common salt, chromium, contains only two elements. Okay, dear students, next write pure mixtures versus Pure substances versus mixtures worksheet. Write down in a notebook and complete this worksheet. And next also this worksheet also completed, dear students. Element, compounds and mixtures. This word church puzzle completed this word church puzzle. And next one, complete this question type puzzle. Is matter pure? And complete this worksheet. Pure substances and mixtures. And last and final, this is also worksheet. This worksheet is also completed. All points, all important points, write in your notebook carefully.